Right, done it, Rachel. Okay, so I'm going to hit the record and then introduce Frank and then hand the microphone over to you, Frank. Okay, a very big welcome to Pennine Ham and the first meeting after our very short summer break in August. Good to see people again. Hope everyone is well and you've got lots of radio stories to tell us about now or over the next few weeks. Delighted to welcome back Frank, K4FMH, who is a regular contributor to meetings of our club and prior to that to Denby Dale that many of us were part of. And Frank has given us some very, very interesting talks. He gave a talk some while ago actually now, based on work that he had done with Dr. Scott McIntosh, which was challenging quite strongly the kind of predictions of the Sunspot cycle 25 that we're in at the moment, and setting out a slightly different interpretation of the data and predictions about where it was going to go. And we thought it would always be good to get Frank to come back, and I know he's done some work with Scott McIntosh as well in the last few months. So I'd very much like to welcome Frank, both as someone who's got a lot to contribute to, but also as a regular on the ICQ podcast, which many of our members listen to. And Martin, M1MRB, is a member of our club and comes along regularly to the digital net and sometimes to these meetings when they're not recording for their podcast, which take place at pretty well the same time on a Wednesday, so I can understand the clash there. But I know we'll catch up with Martin at the National Hamfest on Friday this week. So Frank, over to you.
Thank you for that wonderful introduction, and I'm delighted to be asked to speak to you again. I think it's probably the highest honor if a group has listened to you natter about whatever's on your mind, to actually be willing to suffer through it again. So I'm delighted that you want me to come back. I'm going to share my screen, and let me make sure that now verify that you're seeing my PowerPoint. Nick, does that look okay?
We can see that, yeah, in its entirety. Yeah, brilliant.
Okay. And audio is okay.
Audio is absolutely fine.
Thank you much. Well, again, thank you for having me once again. And I know the first time that I gave a talk to you, Scott and I had just published a cover story. Elaine decided to put it on the cover of Radcom. We were flattered at that. And it was kind of challenging in both content as well as challenging the reigning official forecast. And such is science. I know we got a couple of physicists in the audience, and I'm sure they certainly recognize what happens with that. Sometimes I hear ham radio operators in a debate about antennas, grounding, what have you, make the argument, you can't change physics. Well, gosh, physicists can. How do they do that? They come up with another theory. And I know when I was studying physics as a school child, the term neutrinos or quarks or many other pretty common concepts in physics today were not there. So let's all remember that that's what we're doing. And the title of the talk is Progress in the Revolution, Sunspot Cycle Forecast Accuracy at Cycle 25 Peak. And, you know, let me just kind of walk through some of the preface to some of this, but I'm going to tell you right now, I'll cut to the chase in this talk and see who's more accurate, the Macintosh team or the NASA NOAA ISIS team, and who's talking about it, Those are the two major indicators of paradigm change in any science. So here we go, and I'll try to keep it focused on the basics. You know, we live and breathe sunspot cycles. We have apps. We look at them. We check them. Sometimes we get confused that we look at monthly cycles numbers that say, hey, they're really good, but they're terrible today. And remember that daily sunspot cycle is what shapes our ongoing operating. Since 1826, when Schwabe began counting these things, we've just taken them as a given cycle. And you can look there on the right. It's a sine wave pattern. It rises and falls. Now, in the audience, I suspect there are many members of the so-called baby boom. I'm certainly one. I was born in 1952. Look at cycle 19 that was very prevalent in 1960. I was operating one of those dreaded citizens band CB radios in the United States. I was not a licensed ham. But I did have a 500 watt amplifier, terribly illegal at the time, a 5-element Yagi on a pole. And I used to talk to Columbia at almost every lunchtime during the summer here during this cycle. And it was incredibly easy to talk almost anywhere on 27 megahertz or in any of the many of the higher frequency ham bands. So I know many of you remember that famous cycle. It may have gotten many people into ham radio. However, we tend to take it as given. There's really not much in the way in amateur radio literature that asks why. Why do these things differ? And you look at this graph and you see, yes, there are rise and fall, but look how different they are across cycles. The causes of the amplitude or the modulation. At best, we tend to have a theoretical curve fitting. And I taught statistics. My PhD is in sociology and statistics, and I taught many engineering students. And I could tell the students in my classes who had already had the engineering course where they had to compute fast Fourier transforms. Now, how did I know that? Because every problem that I came up with in statistics, oh, we can do that in FFT. Let me show you how. You remember the small boy gets a hammer? Everything's a nail, right? So I'm not surprised that many in amateur radio who come from perhaps an engineering background where we can just fit the right curve, we can really explain this. Now, over here in the States, Carl Luschel-Schwab is an engineer. He's an extremely smart person. He's done a lot of writing about propagation and is just a really smart fellow. I have a lot of respect for him. I do disagree with him. Now, he says that the problem is we just don't have enough cycles of data that have been going on for millions of years, and we only have this little small window of data. So my response is, so are we just got to wait till we got enough data? Here's the point. No theoretical discussion of antecedents. We only talk about the consequences, right? So those curve fitting tools, while they're atheoretical, they're also not very accurate. And you can look at the current cycle 25 and the official forecast to be very much like cycle 24 with just a little bit of an adjustment. But look at the observations. They're just not very accurate. Now, Eric Nichols, not to be confused with Steve Nichols on your side of the pond, both very bright people, both experts in this particular area, have written a lot, written books that are very influential. Eric Nichols exclaimed in 2015 in his book that the top experts in sunspot cycle-based propagation are unable to identify the peak or the trough or the timing. So this devotion to an 11-year sine wave, it's very sterile, and it hurts science development. It hurts the development of science when we don't focus on theory. Atheoretical predictions are not very accurate. If you don't believe me, just ask your favorite quantoid, how much money have you made on the stock market? So the official forecast for several sunspot cycles were prepared by a team of put together by NASA, NOAA, and ISIS, not necessarily their employees. So when we see something comes from NASA or NOAA or ISIS, we tend to think about supercomputers. I've been a badged official for NASA at the Stennis Space Center. I've seen supercomputer rooms like this. This is not the one, but it's a picture of that. We often in ham radio think, well, NASA did this. They must have these supercomputers focused on it. Not really. Now, these panels are experts. They don't tell us their methods. They do list some models that were submitted to them, and they come up with a consensus. No supercomputer at NASA or NOAA was involved. Now, there's a place for this. I was on a panel such as this for the U.S. Department of Agriculture. Our main job was to monitor the census of agriculture and to determine what a farm is. And you think, oh, how trivial. Well, it could shift hundreds of millions of dollars depending upon what level of production you make a farm defined to be. We use an expert panel to determine when we're in a period of recession. It's not just a number regional scale. So there is room for this, but it is outside the normal peer-reviewed science where you have a full disclosure of data, methods, and results. So this has been a panel of experts that have no peer review, which is the cardinal element in all science. Some of you know this as well or better than I do. We look at this so-called wheel of science where we have theory, we have some hypotheses from this, and if this theory is right, then thus and so should happen, and thus and so here should happen. So then we make observations and measure, we analyze data, and we come back, well, how well did our theory fit? Now, to make progress, as most philosophers of science would say, you need both theory, some kind of understanding. Storks may be related to babies that show up on the doorstep, but gosh, we don't really think they caused them, do we? So we need to have a theory that goes with data and particularly forecasts. Now, Dr. Scott McIntosh and his team of scientists offered such a challenging paradigm. I talked to you before about it, and we published it. Now, and his work was met with rejection after rejection beginning in 2012, and it took 8 years for it to get published. Why would that be the case? Well, briefly, I'll certainly explain that. Here's the Radcom cover story. We went through in some detail what his theory suggested, what the consequences of his theory versus the traditional forecast, and he had two key elements. And Nick, here's where I'm going to focus on the key parts of his ideas. One, and he's had great fun with this, from the Terminator movies. The event called the Terminator is a landmark event in the sunspot cycle, which delineates when one cycle starts, when that cycle ends, and the overlap of sunspot cycle with the 22-year Hale magnet cycle, magneto cycle, the Terminator, an important phenomenon that they've identified as a key theoretical construct. The second is the timing of the Terminator. What's the difference between when one Terminator occurs and the next one? And the variation in that timing makes all the difference, according to the McIntosh group, in how big the peak will be in the next sunspot cycle. So if I were in class, I would say, boys and girls, remember these, they will be on the test. So they are the key elements of the McIntosh theory. So what? Well, here's what. We've got these anomalies where the official forecasts don't work very well. Why is that? They're not taking into account when the Terminator occurs and the period and the timing of that Terminator. The shorter the time, the higher the next peak. The longer the time, the weaker the next peak. And if you just curve fit, you're just relying on all historical data to give you some sort of mathematical edge. And there's a great body of work in that literature and statistics I can certainly underscore. So the cornerstone thesis in this competing paradigm, which addresses many of the anomalies that both Eric Nichols, Steve Nichols, and Carl Schwab have talked about, lies in the terminator and the timing of the terminator. Now, this will be the most complex graph I show you, I promise. Here on the left, we've got what the smooth sunspot monthly peak is. And you can see our friend Cycle 19 that may have gotten many of us into amateur radio. It's almost 300 at the peak. This axis is how many years was it between terminators? So remember, for 19, it was less than 10 years. We had some that were a little less than 9 years. And so the Macintosh theory would be, wow, we're going to have a really, really strong one. Well, they had to guess when the second terminator was going to occur and when they made their original forecast. So it came out to be almost 250, and it got everybody's attention. And they said, wait, remember, we're guessing here, and we'll have to measure and figure out when it occurred, and we'll revise our projection. And they did. And it strung out a little over a year, from about a little over 9 years to almost 11, right? So they revised it. But look at the timing of the terminator and what the peak is. The longer the timing, the weaker the peak. Now let's look at it in an animation. The Hale 22-year cycle became popular in the early 1900s. And his work focused almost exclusively on the magnetic properties of the solar dynamo, what's going on inside the sun, the plasma and how it works, and that sort of thing. I won't go much into that. But look at how these magnetic bands on the sun migrate to the center. And as they migrate to the center, you can see we've got two things on the right. It moves up in our peak. This black line is the overall sunspot cycle. The blue and red lines are the hemispheres that don't always work together. Don't fully understand that. That's work to be done, but you can see that the different hemispheres may work differently. My little joke is this is the Batman signal. If you remember the Batman movies, you got the pointed ears here. And the reason that there tends to be this is these are not perfectly in sync. But these are the bright point measurements, the so-called butterfly wing diagrams. When they come to the equator, look at how they flip. And this was Hale's contribution. And as these magnetic bands flip, the sun changes in what it's doing in the dynamo. The timing here between these sunspot cycles is what sets off the peak. Notice this one on the right has a smaller peak than the one on the left. Now, let me try to bring this to a real world. Nick and I were talking about electric cars before we entered the formal recording. But let me ask you, for those of you who use petrol-based cars, every one of you, I'm sure, has a gauge on your dashboard that tells you how much petrol you got, right? Have you ever watched your petrol gauge go down to empty and yet your car still runs? Well, how can that be? Well, we know how that can be. Why? We understand that there's something else going on, that there's gasoline in the gas tank, there's a float in there that's our meter reading, and then there's gas in the fuel line. Now, if we think of that gauge on the dashboard as the sunspot count, then we're missing the underlying process. We hams often think the peak is the highest number, or the trough is the lowest number, but that's like using your gas gauge for petrol on your dashboard. There's an underlying process, and the Macintosh team is talking about that process being the terminator when these bands flip their polarity and the timing between them. I hope the gas gauge is a little bit of a real world example of what I'm talking about. Sometimes what we measure on a meter doesn't completely coincide with the underlying process. Now, let's cut to the chase. Where is the Macintosh versus NASA NOAA paradigm at now? How will we know when there's kind of a new paradigm in place? Well, fortunately, we've got a good bit of work in science that tells us how to watch for a paradigm shift. And the physicist, Thomas Kuhn, helped define a model of science. We're going to use that here. And this paper is on my blog at K4FMH.com. There are two questions that Kuhn says we need to ask. Is the competing paradigm producing scientific results that are better than the reigning paradigm? And in this case, is the Macintosh team's forecast of cycle 25 more accurate than NASA NOAA? The other element that Kuhn talks about is, are other scientists engaging with the key papers that outline the competing paradigm? Are they citing Macintosh and his team? Are they talking about it, whether positive or negative? The more engagement by other scientists is an indicator of paradigm change. So these are the two things that we'll look at very strictly. Are there better empirical results? And are there more citations of the first two papers that Macintosh and his team published? That will be how we know that a paradigm is changing. Now, this musty old book from the early 60s really set a standard. What he outlines in the Structural Scientific Revolutions, I've used as someone who's worked with the National Science Foundation and the National Institutes of Health and the Department of Agriculture to look at promising young science that needs to receive funding. Well, how do we know? Everybody says their stuff is great, right? Well, we can use some of the elements from Kuhn's book to identify what is very promising new paradigm-changing work. I'll go through this briefly. Here's a diagram that we've annotated. Back when Schwabe and then Wolf, who succeeded him, began to take observations, they were just kind of mechanistically recording these things. And gee, isn't it puzzling? Schwabe said, well, my data says a 10-year cycle, but I'll give Carl Schwab his due on this. That was because he had too short of a series of data. Wolf began to see it was more of an 11-year cycle, and it's been thus and so ever since. Nobody tried to explain it. They were just recording it and looking at it and looking at those measurements. Well, a bit later, when people began to use this, and you can count on that 11-year cycle, that current paradigm says, okay, we can count on this. This is going to happen. We can take this to the bank. It's going to be about 11 years. We don't really know why it varies yet, but we'll figure it out. So the scientific community knows what the world is like. But then when you start predicting it based just on the past behavior, an 11-year a cycle, you don't have results that work very well. This is called anomaly detection. And if you're a young whippersnapper in graduate school and you go to your professor and say, you talked about this in class and I use this fancy curve fitting program and, it doesn't work. Oh, you must have done it wrong. Go back and redo it again because this is right. This is the kind of paradigm thing that I'm talking about. And as these anomalies occur, top experts can't agree whether we're going to have the best or the worst. Gosh, but do we have anything else to go by? Here you have a rebel in the field of science who comes in with a different model. What happens? It gets rejected. Well, this can't be right. We've been doing this for a century. This new stuff, it hasn't shown us that it works. And this is called boundary maintenance. So it took 8 years for Macintosh's team to compile all the data in existence, as the reviewers kept asking for, to show, yes, this seems to work better. So he finally published this paper, and once it was out, the cat was out of the bag, so to speak. Other people began to look at it, and this website in Austria was published that put observed sunspots, NASA NOAA predictions, Macintosh predictions. So every month, scientists could look at the scoreboard to see who was ahead. Now, we think that as of right now, at probably the peak of cycle 25, the paradigms are in model competition. The horse race is on. We've released the hounds of who's more accurate and who's talking about it. Okay, enough of Coon. So where are we? Are they more accurate than NASA NOAA? Well, here is that website in the Austrian Space Weather Office. Here's the URL. It's kind of a famous one. Black is the observed monthly smoothed ones. I want to point this out. Look at these little green lines. This is what affects our daily propagation. So when you go out about here and you say, oh, it's great, but that day you're down here and you say it's terrible. This is why. Remember, the daily sunspot cycle influences our realized propagation. The smooth monthly is a data visualization tool to help us see the patterns without this. Now, so the observed is in black. The two versions of blue are NASA NOAA. NASA NOAA, if you're a track and field person, you know, sometimes there's a false start and the race official will declare a false start and put the runners back on the starting line. Well, they kind of said they had a false start, so they wanted a do-over. I think we call that a mulligan in golf. If you're playing the old course, maybe you can get a mulligan here. So we used NASA's second one, that when they shifted it back 6 months, as the NASA NOAA official ones. And so the red is the Macintosh team. And so you can see, oh, wow, well, okay, neither are perfect. And Macintosh, it seems to be closer to the black line, but gosh, how do we really know? Well, statistics can come to our aid here. I will point this out. The Macintosh prediction shows more of a falling off a cliff beyond the peak, whereas NASA NOAA has a flatter tail off. We'll see who's accurate, but at halftime, if this were an athletic event, who's leading at halftime? And that's kind of the fundamental perspective of our paper. So let's compare the two forecasts, one for monthly sunspots and one for our other friend, the solar flux index. Now, let me explain what is on the graph here. I'll give you 1 second just to take that in. On the left, we don't have the forecast, we have the errors. How much was the NASA NOAA forecast off from the actual sunspot count, right? Well, you can see the green line is the official forecast. You can see the red line is Macintosh. Well, the green line never hits it right on the money where error is 0, right? So Macintosh gets it right at least 1 month, if not 2. There's another one that got it just right, 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 but they missed 2. Neither is perfect, okay? Well, these are in absolute counts of sunspots. So NASA NOAA was off by about 45 sunspots on the average every month. So each month, their average error was 45. The Macintosh team, 26 and change. You might round it 27, but so 45 versus 27. Well, a little more accurate in terms of the Macintosh team. And it's statistically, if we say, well, there's a lot of variability in here, is this significantly different? And well, yes, it is. Very little chance that these are not significantly different. Okay, well, that's in the metric of the number of sunspots. Let's put it in a percent form. What percent are they off each month? Okay. And so you can see that they're each some doing better than the other, but on the average, over the first half of this scientific competition, NASA NOAA was off by an average of 38% each month. Macintosh team off by 25% each month. And yes, that is significantly different. So for the accuracy of the two forecasts, the Macintosh team is significantly more accurate. What about solar flux index? Well, same type of graph. This is the SFI metric, that is the number of units on the solar flux index. And you can see here that Macintosh gets it right some months, NASA NOAA doesn't. That difference is 40, I'll round both to the nearest number, 43 SFI points off for NASA NOAA, 17 off each month for Macintosh. So yeah, they're significantly different. Much better. I mean, if you double 17, it wouldn't reach 42. So it's kind of at least twice more accurate. Let's put this in percent form, and you can see about 28% average error for NASA NOAA and about 11% error for Macintosh. So both sunspots and SFI goes to Macintosh at halftime. Well, are other scientists using this new paradigm? We use what are called bibliometrics, kind of a fancy word for looking up citations in science and seeing who cited the Macintosh exemplars, as Thomas Kuhn called them, those papers that introduced their ideas. Now, this measures the behavior of the scientific community, and this is important to measure when is a paradigm shifting. If other scientists aren't talking about it, then it's not being adopted. And I've done this in many areas of science, and I will tell you, the astrophysics data system that's maintained by Harvard on behalf of the Smithsonian with NASA funding is outstanding. They do a lot of very good data compilation and have tools built into that site that they use to measure the impact and influence of scholarly works in astrophysics. So this is what we used here. Here's a graph that looks at the first exemplar, and this was the first paper that they published after 8 years of trying to get it published in Frontiers in Astronomy and Space Sciences. If you've not had any exposure to some of this, the impact factor of the journal is a metric that says, how important is this journal? Well, it has a 2.6. And that tends to be somewhat important in that as this goes. So this paper was cited 73 times between 2020 and 2025, realizing that 2025 is not yet fully realized. So you take that one with a grain of salt. And you can see that after it was published, it began to get significant number of citations. The blue here is refereed papers, and the green is non-refereed. Well, people will write a paper, they'll put it out publicly so you know what they've done. Then they'll have it under review at a journal. And so putting it out on a preprint server is what they're really, really talking about. Well, print publications, and I've been editor for Taylor and Francis, the oldest academic publisher in Britain. There's a rumor they published the Holy Bible for the Church of England, and that was a real top product for them. And I've been an editor for Springer Media in the Netherlands, a very large scientific publisher. So a lot of this work gets out on these websites, and the ability to cite work in your work that you're doing before it even gets published is a key part of the movement in science. And it's just a function of the internet, and it has sped up scientific progress significantly. So there have been some alternate metrics, and there's a system called altmetric. So they come up with an attention score for this paper. How much attention, particularly outside of refereed publications, before it gets cited, because it may take a year or more to get cited. If you think that's odd, over here in the States, QST, if you have an article accepted, I just had one accepted about 4 months ago. They said it may be 2 years before it comes out. So it got an attention score of 858. Okay, that's the number one figure out of about 1,850 articles in this journal. So it was ranked number one of all the papers published in that journal. It was 813 out of over 500,000 articles that came out in 2020. Now let that sink in for a minute. Of 500,000 articles in this field, this ranked 813 in terms of how much attention it got by other scientists. It was number one of 41 articles that came out at that year in that journal. Number one. It's in the top 5% of all research articles ever tracked by Altmetric. That was the first exemplar. The second, where they took apart the Hale cycle, and that little animation that I showed you that's linked to the rise and fall of the Sunspot cycle, it was their second paper. I'll go very quickly. It's a more recent paper in 2023. Its attention score thus far is 654, but once again, it was number one out of almost 1,600 articles in solar physics. 999 out of 500,000 articles that came out in 2023. Number one out of 106 articles that came out in 2023. And again, in the top 5% of all research articles ever scored by Altmetric. So both exemplars are in the top 5% of all papers, regardless of topic, ever tracked by Altmetric. Now, okay, so is this just sort of something that got a lot of attention, and it's not really based on a scholar that has merit? Well, here's all of the work by Scott McIntosh since the year 2000, 457 papers, and you can see how his citations have just increased and increased. The Herschel Index, I won't bore you with too much of this, but I'll be happy to talk offline about it because it's something I'm very familiar with. The Herschel Index, this little blue line, is sort of the common metric that if you apply for a faculty position, the search committee will want to know what is your H index, or they'll look it up. It's a measure of how much influence you're having in the field. An H index, if you've been in the field 20 years, if you get a 20, that's considered good. If you get a 40, that's outstanding. 60 would be where Albert Einstein and others would be truly exceptional. Well, you can see McIntosh is now right at 50. So he's between outstanding and exceptional. And you can see all these other metrics that are there. And all this is in the paper and my website, K4FMH.com. Now, let's cut to the chase. Is there demonstrable progress in the scientific revolution? The empirical accuracy of the two forecasts and the scientific community engagement. Well, we were trying to see if there's Kuhnian movement. Is there a better forecast, and are scientists citing it and are taking on this new paradigm? And this is science at its best, where you have new theory and better empirical results, just like we had the development of the mRNA work in viruses in developing new vaccines. It's a fundamental breakthrough, and there's so much in the way of mRNA citations. It's not unlikely. So the McIntosh team, significantly more accurate. There is really surprising amount of scientific community engagement. I was a little surprised when I compiled this. A lot of engagement. So where are we? I think this suggests we're here. The horse race is on. The collective behavior of other scientists are engaging with this. And we will wait until cycle 25 is over, and we'll repeat this analysis to see over the full cycle 25 who won at the end of the athletic event, and are other scientists favoring this new paradigm. But certainly at halftime, there appears to be progress in the revolution. So I will end it with that, Nick, and be happy to talk to anybody who has questions, and I'll do my best to answer them.
Frank, as always, that was a wonderful presentation and full of interesting thoughts and ideas and challenges in there for all of us. Obviously, as radio amateurs, we're the ones making and contributing to making observations about what it actually means for us in reality. But it was a pleasure when a few years ago Scott McIntosh and his collaborators came along and challenged some of the orthodoxy, and part of it being interesting to us, I think, was because it was telling us that solar cycle 25 was going to be better than was predicted by the orthodox way of predicting it. And of course we want that because we want to play radio, and we want the solar cycle to go on for a nice long time and have loads of DX that we can hear and work for a nice long period of time. So obviously we wanted that, but it's fascinating from the work that you've just explained to us, Frank, to see how the prediction that was made was certainly, as you say, at possibly past the half-time mark yet. We're not sure yet, but probably past the half-time mark, that actually the Scott McIntosh viewpoint is much closer to the reality of what we've actually seen. So just on that, I saw various people smiling at various points as you were talking, Frank, and enjoying some of your examples you were giving there. So let me just throw the meeting open and see who wants to go first with a question, comments on Frank's talk tonight. And I've popped a note in the chat box on YouTube for those watching this live on YouTube. If you've got a question you want to put to Frank, type it in the chat box there, and we can feed that back into this discussion. So let's go into the meeting first of all. Who'd like to go first? Yeah, Roger.
Yeah, thanks, Frank. Entertaining as always, and given your early admissions about the power you were using in the first before you got a license, I'm glad there's a statute of limitations and probably run out on that. I wonder, now that they've got this theory and everybody's taking it seriously, has it helped other scientists to develop the theory of what's causing it, the underlying theory of the science of the sun, as it were? Because it's all guesswork, isn't it, at the moment in that respect?
Well, thank you, Roger, for that. And yeah, as I said in the prologue, and I think us amateurs come from all walks of life, right? You can't change physics. Well, physicists can, because they come up with new theories. So, and so this is a new theory, Roger. And as you said, it's guesswork until you match it with data, refining then the ideas based upon those data and coming back again. So in the citation part, which might just kind of seem like gobbledygook, okay, you went to the library electronically and you saw who's talking about it. Well, Roger, that is the collective behavior of scientists. And what motivates scientists? Well, I think Kuhn said it very, very well. What motivates scientists is puzzle solving. When you get into normal science, he or she, unfortunately, it was he mostly, but I'm delighted that those doors have been broken down, and I hope forever. It's he and she are solving puzzles and moving things ahead. Now, McIntosh's group, and I talk with McIntosh a couple of times a week. In fact, I had an hour and a half Zoom conversation with him this past week. about terrestrial impacts and some thoughts I had about how do you measure some of those impacts, because that's where we live, right, Roger? I mean, we want to know what impact, right? Well, as Einstein once said, there's nothing more practical than a good theory. So I think the work is in refining the theory, developing measurements of the terminator, and they're very close to predicting the terminator. Okay, so what? Remember, the timing of that terminator is going to set up the next half dozen years, right? Good or bad? Well, it's much better than what the official forecast were going to be, which was going to be another cycle 24. So where they were wrong, they predicted where they'd be wrong. They estimated the terminator would come about a year and a quarter earlier than it actually did. So the next work, Roger, is what they're doing now. Can they develop a better prediction of when the terminator will happen next? Because it's the previous terminator. Now, when's this next one? When's the next one? Earlier, later, earlier, later. It's got the big impact upon the peak, right? And so that's where they're working right now. And Scott tells me, and Bob Lehman on the call, they're making some work. If you want to see the future, look for Bob Lehman and the solar clock. If you can't find it, pop me an email. I'll send you the paper. Bob Lehman took the lead and developed a round solar clock. We put hours on it. He put sunspot periods on it. Are we in phase 2 or phase 3? That's coming, Roger, and that's where their work is. Where's all these citations going? All these other scientists want to go, well, I can do better than that. I'm going to make it better. So they're going into it, and that's the good part. If you believe in competitive economics and the economics of the marketplace, it's that free market. It isn't totally free because some people get more money to do research than others, right? And I must say, from this side of the pond, you get your money cut, then it retards your science, and that can happen. So they're out there in a feeding frenzy on this new paradigm, either trying to find problems with it or find good parts that they can add to it and push it forward. I do think we have something to add, and that is the Whisper database. Now over a sunspot cycle in length, several terabytes. I have it all downloaded on one of my machines. And one of our little discussions this past week, what can we do to get some preliminary prototype data to show the impact? And Roger, I apologize if I'm opening up a fire hydrant to answer you, but you ask a great question. So what happens when you have a higher peak than before? It tends to drop off, but you also apparently have more solar storms, right? So right now we're having a lot of solar storms, and us hams are going, now wait a minute, I thought that Macintosh guy said that the fishing was going to be great. The fish were going to be biting, right? Yeah, but you're on turbulent seas too, because there's a lot more energy there in our part of the solar system, and it's coming. So we are in an exciting time where there is development coming, and Macintosh will tell you he's not right about everything. They've been wrong about when the initial terminator, the second one, was going to occur, and so 25 is not quite what he had hoped earlier. And we're going to dip off. You know, we're going to go down more than if we'd had more of a mundane cycle. You know, because it's going to kind of stay there. Anyway, I don't know, Roger, if I've addressed it or not. But it was a very, very good question, and one that I'm trying to keep up with Scott, and I'm going back and reading 100-year-old solar physics papers and finding where some of them were saying, you know, there's something about the bottom of this solar cycle that happens, and it really changes things. And now Scott's telling us how those things work.
It's absolutely fascinating. Thank you. I mean, and it's interesting, like you say, that a relatively simple kit can perform a useful function still. You know, it can gathering data and that can have an input. And it's everyone can all contribute in small ways.
Well, imagine, Roger, if we had a website where some of the fundamentals at least are beginning to come together, where when you can predict more accurately when the second terminator was going to occur, so you get a better prediction of the next solar cycle. And as you go through that solar cycle, you begin to link solar storms, because the peak is related to the storms, right? Got more energy, going to have more storms. And like right now with terrestrial weather, when it gets hotter, there's more energy in that system, and you're going to have more intense storms. So there's an analog there. What if we can then know the metric of the impact when that solar storm's coming? You can decide, boy, that contest I was going to get in next week is not going to be worth my time, because it's going to be radio silent. And these daily fluctuations, one of the things I've tried to do is to get people to realize the smooth monthly. And as I've said, and I've made some of the luminaries like Lucial Schwab and some others mad by saying this, no smooth monthly sunspot number ever affected your propagation. It's only the dailies that really affect your propagation, right? So that's in the foreseeable horizon, Roger. I got a little bit of optimism, of course, but when I first interviewed Scott for the ICQ podcast several years ago, he had me when he described a new paradigm. And I likened it to when a young upstart Albert Einstein was challenging some of the luminaries and does light bend, and you can test it by an eclipse. So the Royal Society of Great Britain funded, along with some others, some people to go to Brazil and some islands where they could get photographs and they could see. And the London Times was waiting for those plates to come back and to be developed. And now we see it on an Austrian website, every month. So it is indeed an exciting time. If we'll play along and spend a little bit of time learning maybe some of the nuts and bolts, it begins to open our eyes there.
But no, so it is fascinating, and it's like you said, we've just in the UK here, just the last few days, we've had reports, lots of pictures of the aurora being visible again. That's an indication of, like I said, the big solar storms. Anyway, thanks, Frank, again. We'll look forward to seeing you in another few years. And,
Thank you, Roger. Anyone else with a question or comment they'd like to put to Frank? Everyone's going to go quiet now.
Well, I want to call on Rachel, and I will tell you why I want to call on Rachel. When she introduced herself, her good evening reminds me of one of my favorite British hams, Leslie Butterfield, on the podcast, because we all mimic Leslie Butterfield when he signs on saying, "Good evening, Mark." So, Rachel, I loved your good evening. Do you have any thoughts, Rachel?
Not yet. I was just looking for this paper you were talking about.
K4FMH.com. And that's my blog, and it will be there. But I didn't have a difficult time selling you on the halftime concept. I'm looking at your background picture. So you bought into the athletic event, I can tell.
Well, I'm eternal optimist. I'm a Tottenham fan, so I have to be.
Well, as I tell people, I don't play on the soccer club. I'm the cheerleader telling people about what they're doing. So I'm not a solar physicist, but I have studied science for several decades. As a statistician, I've had the pleasure of working with Scott, and he's thanked me a time or two in some of the papers for helping him shape some of the analytical details and stuff. So I'll put myself out there as a cheerleader for him, and pleasure to work with him. And it looks like we'll continue to do some work, because there is work to be done. There are other questions? Anybody from YouTube or
No one's popped in a question yet on YouTube, but I've popped it in again. If anyone's got a question, Frank. I just wanted to put to you that what you were describing in terms of changes in scientific views and understanding, the process you described there is the same in whatever field of science we're working in. So we're talking about solar physics, and in particular, the effect that the movement of changes in the sun make to propagation of radio waves inside on our planet. But the same, what you described, obviously, in terms of the challenges that come to orthodoxy, is about how everything develops, isn't it? How science develops.
It
and
is.
how everything that we use and play with as radio amateurs, all those things are a process. So it's I've always thought it very unfair that, one or two famous scientists are named as the discoverer of this. Well, in fact, that's obviously not the case. They might have been at the heart of it, or they might have had more money than other people, but you just know there was a pile of other people also working away on this, contributing their ideas and their thoughts and their work that eventually led to those changes in understanding. And part of Roger's question, I think, was an important one. I know that we don't really know enough about what impact these magnetic changes on the sun make on the planet here, and particular to radiation of radio waves. We're still not sure, are we? And I know that scientists are still we're probably still only at the baby stages of understanding a lot of this stuff. So even though, going back, over 100 years now to the work of Maxwell and so on about, electromagnetic waves, we're still at a very, very early stage of our understanding. But for us, playing in this as a hobby, it's so important to us. And we want to have a good understanding of it, don't we?
We do. And let me make two comments. One being my PhD is in sociology and statistics. I'm minored in computer science. To study the social institution that is science, like religion is an institution and the family is an institution. But to study science as an institution, I find it very fascinating, because many of the battles, and you think of Nikola Tesla and how he was sort of given short shrift in many of the ideas. Now we have all these conspiracy theories about what Tesla said, and we don't have any evidence because the government took his paper. I mean, you get into some of that, but you look at science in specific areas of science and how things move slowly and then change. Well, I'll use an example, and I sort of tease some of my friends of what, you can't change physics. Oh, physicists do. They come up with a new theory. And I say Rachel nodding, and I'm going to look to why. Well, when I was taking physics in high school as a lad, I had what we thought was a boring teacher. He had a dry sense of humor. And some of us guys who thought we were athletes and who were waiting to go to the gym to do what we really wanted to do didn't want to pay attention. And he would talk about the world is composed of, and I may get some of this wrong, neutrons, photons, and a whole lot of morons. Well, and as I like to say, take the morons out, but I don't remember neutrinos or quarks. Well, gosh, how did that happen? The electron microscope happened. We suddenly had technology of which we could measure things, see things, if you will, by sensor underneath that level of conceptualization. And so these concepts get changed so that, we can't change physics. Oh, yeah, we do. Remember the debate over cold fusion, where, and I forget which law of thermodynamics was being trampled upon, where more energy was being created, than was what was put in. And people in the U.S. state of Utah, they got their politicians in it, and they had demonstrated this. And there was two chemists teaching the physicists how the world works, right? There you get another little conflict, Nick. You get the different disciplines and their boundary maintenance. Well, we then developed a field called biochemistry, where they do have commonalities, and it was predicated a lot on the tools for measurement. Well, let me come back, and I know we got a hand up here with Ken, but I want to come back to your second point here. That's the social science of science and how it works. And very often I'll talk to engineers and they never took any of those classes and don't, they feel like I'm a scientist, I know science. And I've run into discussions with some on QRZ who social institution science is not a social, just don't have any idea about that. Well, I'm ignorant about a lot of things. I just try to realize what I'm ignorant about if I can. The second part of what you're talking about, the Parker probe, I think has been a potential breakthrough. I'd like to joke, oh, so you really know what's inside the sun? Have you gone and put your head inside so you can really see what it's like? No, you haven't. But the Parker probe has come close. And the other tools that we have on sensors to measure many of those magnetic fields and to simulate them, we've come a long way. It's as we get closer, and if you think of Tamitha Skov, her common name, popular name, Space Weather Woman, tremendous scholar, and beginning to look at when a flare, when a storm is coming, what class it is, how close it's going to be, and as we enhance those measurements, we may be in baby steps. We're going to begin, as Forrest Gump said in that movie, we're going to be running pretty quickly, I think. I'm like Rachel, I'm an optimist, though.
Ken, over to you. Ken, you're on mute.
Yeah, okay, very good. Thank you, Nick. And thank you very much there, Frank. My question to you, Frank, is not actually about the theory of all these cycles, but it's on more of a practical side. Right. I have been licensed and probably experienced 4 or 5 even, or nearly 5 Sunspot cycles now. But I can't remember in my time where we have had so many CMEs which have affected the band conditions on HF. And I can't remember it even being mentioned previous to, say, the last 5 to 10 years. Has there been any data, any analysis on this on previous Sunspots 11-year cycles? Because we have, although we've had a fairly, I think, an excellent cycle 25 so far, it's been marred by the CMEs, which sometimes have taken the bands out for 2 weeks or more. And what are your thoughts on my points of any analysis on the CMEs and what's happened during cycle 25? Like I said, I don't even remember them happening on cycle 24.
Ken, a great question. Let me just observe over on one of my monitors. I have 3 monitors here at my main desk, and in the lower part of one of them, I have Whisper.rocks that I tend to monitor. Great website, I think. I have a Kiwi SDR that I keep turned onto 20 meters. I'm about to add a Web 888 and enhance some of those. But there were only 2 stations that I heard in the last hour on 20 meters, for example, because of the storm we've got coming in now. So your point is if you'll allow me to intentionally make a pun, you are spot on. You are sunspot on with your observation about the CMEs. Now, I'm sure that there is some analysis. However, I think in the main, it's mostly what we would technically call anecdotal. That is the experience of a single ham, like you, for example, or like me. And this is why in talking with Steve McIntosh and Bob Lehman this past week, I asked him about terrestrial impacts because he's left the National Center for Atmospheric Research. He's now vice president at Linker Space, a for-profit corporation. And so he's looking at markets for the kind of space weather that he's doing. And some others are too. A lot of the immediate impact is in the world of GPS. It has military security implications here in the U.S. Flex Radio System worked with Raytheon to develop the U.S. Air Force's communication systems. While they can't say what the technology is, I believe automatic link establishment, AIL, that is, the pilot doesn't care what frequency. Find me a frequency that works to go from here to there, right? Probably AIL and some part of it. So when you have a system that is GPS dependent, particularly if you're going to encrypt the comms, right? You don't want the bad people that you're working against to understand what you're communicating, then GPS is a key part of that. And when that gets impacted, then boom, some of your military assets may lose their capability. Now let's go to the practical stuff that you and I like to talk about. What our HF radio is working. So we haven't had wide-ranging empirical data, and we need some sort of signal-to-noise measurement, probably in there, somewhere in there. Whisper, as Gwyneth Griffiths has shown, there's some issues with the noise estimate. Okay, there, but you do have an SNR. You can go to some of the other propagation reporter network and things like that. I work with a group called HAMSci, which is Social Science Investigation. I'm one of the professors there. And so there's some work there to get better monitors, better terrestrial space weather stations, because Whisper is crowdsourced. Individual hams, mostly hams, put up a station, whether it's a receiver. They don't have to be licensed to put up a receiver and feed data back in. They do have to be licensed to put a beacon in. So what I'm doing is putting together the corpus of the Whisper data. It's several terabytes large at this point, 12 years, 13 years. Had about a prostate cancer a little over a year ago, so that project got put on the shelf for a little while, and I'm hopeful to get back to it. But you have to add a lot of things, the angle of the sun, and a lot of other ancillary data. Now, I am trying to answer your question. I'm trying to make the point that, yes, we can rely on anecdotal data, and yes, they are valid. What you've experienced is very valid. I'm not saying it isn't. But to estimate a number or set of numbers of the impact of, say, a CME with certain metrics itself, where and when, how soon will it impact you? Will it impact you all over the globe spatially? Will it impact certain bands more than others? Well, we know the answer to that, right? And so, but to put all that into play and have a system where you can begin to demonstrate that, we've got to have terrestrial data. Scott was not that familiar, not being a ham, with Whisper. It's probably on the public sphere. Now, what we have that's secure data is a whole other thing, right? We won't have access to that. But on the public side, Ken, I think to the extent that Scott and I and others can pull together that Whisper data and begin to estimate some models of the impact of, say, a CME and other storms, and then without storms, and the spatial component of where does it impact on a given band. There are several key variables where you can't make a quick generalization. The bands are dead. Well, 10's popping. Have you looked? Because we're seeing these things. This happens frequently, with people that say never get off 20 meters or something. So I know that's a fuzzy answer, but I think the reality is a little bit fuzzy. We don't know if northeast or northeast or east northeast is the right direction, but it's somewhere in that quadrant. That's where I think we are. From my best assessment, that's where we are.
But Frank, going back to cycle 24 and 23, I wasn't as involved in looking at these predictions 2 or 3 cycles ago. But I mean, the sunspot activity has been immense, I think, in this cycle, and created these CMEs. Are we actually saying that these CMEs have been there all the time on sunspot eyes?
Well, yes, they have been. Now, to put numbers on your question on the spur of the moment, I'm unable to. But I have now gone back to all of over the last few years. I've gone back. I have all of the sunspot data. As a statistician, I've kind of looked at them just to get a feel for, some of the variability. I do plan to build back as far as we have them, our estimates of solar storms and their various classes. So I think to some degree, solar physicists have done some of this work, but they don't think about impacts necessarily for people like us. I mean, that's outside of their purview. This is why I believe ham-sci is so very important to both have practical import to people like us, as well as pure scientific import, because some of these storms, if you'll pop me an email, I'll find the article and share it with you. I think my name appeared somewhere. There's probably 50 authors on one of them. I didn't have much to do with it other than offer my 2 cents, maybe, of using some of the whispering related data to look at the terrestrial impact, because, Ken, that's what we haven't had. We haven't had systematic terrestrial measurements. We've had basically anecdotal and maybe some other things like an electric grid went down here, but not there. Well, maybe one grid was maintained better than the other. I mean, you get into some things where you wouldn't really call it science, you'd call it episodic. So I wish we were further along, but I believe we're going in the right direction. You and I may not live to see it. You and I may not make enough sunspot cycles with me at, say, 72, make it, but I do believe we're heading in a direction where we will know more.
So would I be right in saying to you then that because the CMEs are now reducing, plus we are still having them, but not like we did, say, a year ago, are we saying that now we may be coming out of 25?
Oh, sure. I think Scott feels pretty sure that we are past peak.
Yeah.
And that's why we chose a year ago on our data on that little graph that was a safe, that we're somewhere around peak. Remember the petrol graph and your car running? Petrol, the petrol meter, you're empty, but the car is still running. What? Because we're looking at sunspots only, and what produces them is the underlying process. We do think that underlying process is past peak. Believe that. We won't know till afterwards. But the thing that I've observed with looking at the data, and I believe from learning at the feet of Scott McIntosh and his team, when you have a higher peak sunspot cycle, you got more energy in play, and you're going to have more of these storms. Clearly, there's a relationship, Ken. So your anecdotes do fit what clearly seemed to be the pattern of the data. And I hope we have more of that type of work. So we got to have theory. That's what's been lacking. So many people have done pure models to get what I call a squiggly, some little squiggly that's a little bit better, but you don't. So what? What does that mean?
I just don't wait around to see a couple of more.
I'm with you. I'm with you.
Okay. Cheers. Back to you, Nick. Thank you,
Ken. Thank you, Ken. Jeff?
Okay, Frank, thank you very much for this. This was really science in action. That's what you were telling about. I have 2 observations, and the first observation is that I think that during this maximum, 6 meters was not that good as it was in previous cycles. And the second observation, and is a little bit in line with what Ken is telling, is that I had the observation, and I don't know if that is coincidence or if there are a relation or a correlation or whatever, but when there are CMEs, in the period that there are CMEs, I found that conditions on 2 meters and 70 meters were excellent, actually. I don't know if there is any relation, correlation, or it's simply coincidence. That could be also because we are in the summer, and those things happens in the summer. Good conditions on 2 meters and 70 centimeters. Thank you very much.
Well, let me comment. And Scott appears on the 6 meter group, Frontiers. I forget the full name. He appears regularly there. And once you get above HF, as you know, the relationships with certain phenomenon like this can be different, right? Just like it is on the top band. You know, the top band is better some months than others. And so the frequency variability, some of these relationships are not frequency invariant. That is universal on all of them, right? And so when we start talking about this, Jeff, you bring up an excellent point. Those who don't do 6 meter work or do 2 meter or VHF, UHF work, they're aware of anecdotal observations, just like Ken had, right, on HF. And so these things can be very different. So you almost need a model for the different groups of bands that we have. And some of these relationships will be different. You might think, oh gosh, I'm working 20 meter DX and we're having a CME. And Jeff is going, let me get my antennas ready to go, because suddenly I may get some activity that I wouldn't get normally. So these are some of the nuances that you're spot on, and we will need to tease out of some of these. But as we get more data and get better data on the sunspot cycle and the timing of the terminator, and once we have more data on terrestrial impacts, the whisper data goes back over a sunspot cycle now. It's not the best. How many of you, if you raise a hand, use whisper to maybe test an antenna or something? The problem, and it's great, but the problem with whisper in most of the websites is they've done nothing wrong, but there are a lot of false negatives. Now, what do I mean by that? You've got grids out there. You put a signal out there, right? Now, this morning I was testing an antenna myself, a different one, and that reminds me of something I want to comment on. Nick, you wanted me to speak about. It goes here and there. It doesn't go there and there. Really? You know the old thing about, does a tree that falls in the forest make a sound if no one's there? Well, if there's not a receiver in that grid square,
yeah, exactly,
then you don't know if your signal got there or not. And so one of the things that finishing a paper at some point, again, slowed by health problems, to point that out, that I would like some of the major whisper maps to maybe show a grid where there's a whisper receiver on this band and it did not hear you. And you could turn that on to maybe show that area so you don't get a false negative. But we've made so much progress, and really the Whisper Rocks and other groups have just created fantastic online data that I don't want to sound too critical, but we can always improve. So that's one thing about Whisper, and I use it a lot for practical reasons, but the false negative is what you have to keep in mind with some of that.
I think also with the previous maximum, there was no FT8 and Whisper, so we cannot compare.
Absolutely.
And on the other side, we make contacts thanks to Whisper and thanks to FT8, which were previously totally impossible.
Absolutely. Absolutely. And
also on VHF and up.
Right. And I have an ICOM 9700 like so many do, and I'm going to put up, and I'm in a homeowners association that restricts outside antennas. but I'm going to put up a 1.2 gigahertz antenna, even in my attic for FTA. I may work no one, but I won't know until I try. And
Yeah,
we don't
exactly.
have much 1.2 gigahertz activity around here locally, but until we try, we won't know. So
Exactly. Yeah.
I mean, Jeff, you've hit on the point that Frank was making earlier about data, and of course, you know, if we're looking for real data, in other words, data going over for hundreds or thousands of years, you know, that just does not exist. Or if it does exist, I mean, I know the work that's been done on solar storms, for example, but that's looking at things like, you know, the fossilization of trees, and you know, from an event 14,000 years ago, and then trying to draw some conclusions from that about what that means for, you know, the possible repeat of such events arising from solar activity. You know, that's where I think the difficulty we've got is about, in terms of what we want it for, which is really to look at the impact of these solar and magnetic activity of the sun on our ability to use the ionosphere to send our radio signals around the planet. That's what we are fascinated with as radio hams. The amount of available data to us is very small. And I was going to make the same point you just made there, Jeff. I mean, I think this is even more. I think there's probably more data on FT8 nowadays than there is on Whisper. So you know, if you want to look for how propagation is going, I think that was the point there.
Yeah.
You know, you go on the computer, have a look, and see what you're seeing on 20 meters or 15 or 10 on FT8, and you'll have a sense of what's going on. Then you're thinking, well, actually, I've got a chance here on CW or single sideband on, you know, 10 meters or 12 or whatever it might be. And of course, part of the problem we then got is that it's going to depend on how many people are on the radio at the time you're there as to whether anyone is actually going to reply to your attempt to get a QSO there. So, you know, there's lots of things that prevent us from collecting enough data to make, in my view, certainly even at the moment, you know, predictions of a greater accuracy than those that Macintosh has made about solar cycle 25. But and Ken's point earlier, Frank, was about, you know, there do appear to have been, you know, certainly publicity of, but there probably have been much bigger coronal events, which, although they have activated the ionosphere, they've done so in a way that it's not able to be available for propagating radio waves, because it is so disturbed, it's so kind of angry. So, you know, when we're looking at it, as Frank, you said this earlier, you know, it's not just smooth sunspot numbers we're interested in, it's the SFI index, it's the A index, it's the K index. We can have a high SSN, a high SFI, and then we can have blasted high A's and K's that mean that we can hear nothing, and the band seems absolutely dead.
Let me throw in here just a little bit, and great comments. I'm enjoying this immensely. Some of the work you talked about, what we might be called the forensic research, Nick, where you're detecting in tree rings and other things. You know, the famous Carrington event, I read one study that seemed reasonable. I can't be a good judge of it, that there were actually two solar events that produced the Carrington event. And that's always used. What if we have the big solar storm? Well, there's some evidence that there could have been repeated solar storms that actually caused that. I don't know, but we learned the debate from some of the forensic work that you're talking about. Let me comment this way, and part of the problem of putting disparate databases together, and if there's probably anything I've done in my career, is I've worked with federal government and corporations to fuse data. The big problem is getting common metrics or comparable metrics. What is it out of FTA? What is it out of Whisper? I mentioned SNR earlier, some issues there. Now, as a statistician, I want to make it even more challenging, because as the Earth turns and that solar event hits, where are you on the Earth relative to where that hits, right?
Mm-hmm.
So you've got a spatial component. You also have these other metrics that Nick was talking about, that for the globe, it might be fixed for everyone, right? And then it might vary by spatial location for some other things. And we even get in things like lightning storms. Some of the people here, as we're gearing up, there have been, Ken, I think you may have mentioned there was a big storm close to where you are. Well, that's not everywhere, right? So as you begin to pull many of these things together, you have not just one spot where statistically you're going to look at where Jeff's location is, what's going on there. You've got multiples. And remember, going to make it much more difficult. You have what we call origin and destination, transmitter and receiver. We're not just looking at one spot on the globe, although, hey, if I'm in a contest or I'm doing something, I want to know what's going on with me, right? We all have that. But with me relative to where, Dick talked about where you might be able to work with different modalities. And that is real challenging because you've got origin destination data. Computationally, to estimate those models, to look at, say, the impact of a CME, of a thunderstorm, and other things, you've ramped up the computational needs. Now, I'm not saying you're a supercomputer thing, but you got big data, you got computational intensity, and that was the purpose of my meeting with Scott, was to share with him some of the statistical tools that will allow you to have fixed effect, where you've got one of these indicators that would be the same for everyone, or variable effects. It might affect Nick more in his location more than Jeff with time. It's complicated, folks, and yet we don't have, as it turns out, a lot of research money pointed toward this. I hope Scott's company will get those who are dealing with GPS-based data to help fund some of the research that will percolate down to us where we are. Because as broadcasters who have money in that industry and related, say, cell telephones and others, they aren't too far from us. So even though we're not that important to others sometimes, the frequencies we're on are close enough that we will benefit from the R&D there. I know that was a mouthful, but that's kind of the tough thing about making progress here. And I was sharing with Scott what I used to teach in a graduate course to PhDs and faculty members of geographically weighted regression and the multi-level geographically weighted regression that allows variable and time varying parameters. A big mouthful, I realize, but different effects for different groups and locations, because that's what we're talking about here as we've dealt with a number of these questions. And I hope we're able to, in 5 years that we can say, hey, we're beginning to make some progress. If we can get one solar cycle, okay, well, we've got a model that incorporates many of these things into it, then I think we're off and running to make it better in the future and begin to pull many of these databases together. Anyway, sorry, long-winded answer, but
I think, Frank, I now realize that actually we all contribute to the data, actually, and PSK Reporter and the RBN network and so on. So we are actually citizen science altogether. Ham radio is a citizen science hobby.
And one of the best things you can do, because here in my state in Mississippi, there's almost no whisper beacons or receivers. So I'm in the process of, I've had a whisper beacon up for a while and it went off for another reason. So I'm going to put one of the web 888 ones that'll do all the HF bands at one time and report that back into the system with a loop antenna. And also a beacon that will be on a different transmit cycle than that receiver, on an in-fed half wave that will be in my attic. And it won't be the best, but it will be some data. So I think all of us, if we can, try to support the system, Jeff, that you're talking about by inputting data into it, it can only help us. So.
Yeah. I think also that, I mean, the technical specifications of our receivers now are totally different than 10, 20, 50 years ago.
Yeah.
So
Oh,
that also
absolutely.
makes it difficult to compare.
Well, you're right. As some of you know, and I don't remember if I gave a talk to this group. I think I may have about Rob Sherwood's bench measurements and price and satisfaction and things. And I have him. Oh, I just can't tell any difference. And I go, okay. You ever seen a Drake TR7? I love that radio. But listen to it versus the new Yaesu FTDX10 and tell me you can't hear it. If you can't hear it, please go to a doctor and get your hearing checked. So you can tell differences. Now, as Rob says, the top 10, you may not distinguish much. And as my friend Martin Butler said, that when he was working for a big retailer in England, I won't mention the name, and someone came in and says, which radio should I buy? He would take them over and show them. He says, which one's the prettiest to you? Which one looks the best? You need to buy that one because you'll like looking at
it. Yeah, good.
Frank, lovely. I don't know if we've got anyone else who wants to contribute before we close it down. I just want to give Frank an opportunity before he goes as well, just to tell us about some work he's been doing on something that we'll also enjoy. But before we get to that, anyone else got any other comments on the subject we're talking about now before we wrap that up? Go on, Frank. Go on, Frank, on to where we are.
I'm a member of the Sutton and Sheen Club that friends on the podcast, Martin Rothwell and Chris Howard, among others, are part of. They don't put their talks out on YouTube unless you're a member. It's on YouTube, but you can't get to it unless you're a member, and that's just their club decision. So I've given this talk, but you will not have seen it unless you're a member of that club. I've been building antennas since I was 8 years old. My older brother stepped on a telescope equipped on that famous transistor AM radio that many of us had and broke it, and I cried for hours. But he was 5 years older than me and was a lot bigger, so, what could I do? And when I touched the nub of the antenna at night, suddenly I could hear WLS in Chicago. Well, little did I know, capacitively loading with my body as an antenna. At 8 years old, you don't know that. So I've been interested in antennas since then and built a couple of broadcast stations and have done work outside of amateur radio, but I still build antennas. And when I was dealing with cancer treatment, you kind of have a lot of time to think, and it's amazing where your mind goes to not think about what you're dealing with. And I designed 6 antennas in my head, and they are bespoke antennas. And you'll see the first one probably in the next issue of Practical Wireless, called the Eiffel antenna. And it looks like the Eiffel Tower. I was out this morning testing 2 others, one called the Wavecaster and one called the Random Copper Stick. So Nick, I shared with him, he and I emailed some, and he said, look, as you make progress on that, would you be interested maybe in coming back and my words, not his, boring us some more. And so if you want to be bored some more with some weird antennas that do seem to work, I'll be happy to do that. I think antennas cut across everything we do, so it's a common denominator. And the whole goal here, they're portable and for HF, easy to put up, easy to take down, easy to transport, and they work. So that's what I've been up to. And if you're interested in hearing some more, I'll be happy to share that. So.
I think you got a thumbs up from the room here, Frank. That's
what we are looking for.
They're not as high as the Eiffel Tower.
Well, if you read Practical Wireless, I got the galleys from Don a couple of weeks ago, so I'm guessing it's probably schedule for the next issue, but that one will give you a feel for the kind of shenanigans that I'm kind of up to. It's amazing what you think of when you're in the hospital, right?
Frank, I'd very much like to thank you for your contribution tonight. Really lovely presentation and talk, and I know our viewers who watched it live on YouTube tonight appreciated it, and I'm sure those that catch up with the video over the next few weeks will do so as well. So can we show our appreciation to Frank in the normal way? Yeah, thank you, Frank. And Frank, we will definitely pursue the offer for you to come back and bore us about these antennas that you've been playing with.
Well, there is
I
some
guarantee
boring.
to you, we never bore each other talking about antennas.
Well, there is some boring involved if you think of boring as a drill. So I will say there will be boring involved.
On that note, I'd like to say good night to our viewers on YouTube, and good day or good evening, good afternoon for those that have just finished watching it, if you're watching the video of this. And I'll take down the recording as well. So thank you very much, Frank. Oops. Right, so we're no longer broadcasting on YouTube.